Hello everyone, my name is Sandeep Sharma, and uh, we are discussing here again about and in this discussion and we will solve last two assignment. So in last two class we have discussed about state food, the seed making room, and in this section we will move to uh, grades. Grades. So we will start this discussion with one new problem from last week, and this problem is in a cluster of protein attached to the 20 centimeter with rooted blood nucleus is to be calibrated for a stick. What will be the exposed length of the protein donor for getting the protein? We need to find the exposed length or measure of rooted donor for each for getting the desired stick. So for that, what was the procedure? We first need to find that what is the volume coming in one evaluation of reaching unit of rooted donor. From that volume, we will equate that volume that seeded to the seeded side in one boundary position. So this two going to be able to find that what is the exposed rate. So in one dimension, what is the volume coming out from the plant? So for that, we need to know that what is the uh, what is the area covered in one dimension ground. So this 9 into 20 centimeters square
तो तुम डिस्कनेक्ट कर लो इधर शायद तुम डिस्कनेक्ट की हो? तो मैं हो रहा था आज, पता नहीं मुझे लगा शायद बैटरी इसका चार्ज खत्म है। क्या ये अभी होल्ड में रखा है क्या?
Yes, I saw you got 2.67. Yes, and now tell something.
Sir, am I audible now?
Actually, okay, leave. There is problem with my speaker. So this is 2.57 kg, and we need what volume is same. So what is the density of this seed? First density is 420 kg per inch. So this is divided by 420 to get this is giving 2.5 by 4 kg. 2.5 by 4. This is 0.0. We need we need this volume. And earlier we have derived one equation. Last week we have seen that this is the volume of seed, total volume of seed. So we need to know that what is the volume of seed coming. And this we will equate with what is the volume of seed coming in 1/2. This all things we have already discussed. This last class, this was the volume of system. So here, this will be liter cube multiplied with for centimeter. We will multiply it out 10 to the power plus 6. So this into 10 to the power 6. Are you getting? कैसा आ रही है 6.23 centimeter cube. That is actually a very large. Okay, keep that one. And now we need to know that what is the volume of seed from making units. So for that, volume of seed was area into number of future unit into width of future unit plus 5 s a into a and t l plus 5 ds. For this area, for doing this area, we need to have this questions. One slide one and slide two. And for this A1, we need to have diameter of that larger section. This diameter, then alpha, this included angle alpha, then r square means smaller section radius, then beta. So what are very question? The question we have diameter of rooted area, diameter of larger section of root, and diameter of active layer. So diameter of active layer, this thickness of active layer, this is S, and delta B is M. Diameter of rooted width, diameter of larger section of the rooted line. So this will be the diameter of width, diameter of larger section. This is the larger section. This is the larger section diameter. So we need to know that for this diameter and this radius is given, we need to know alpha, this alpha and this beta. So this alpha will be C. This is alpha. So this will be alpha by 2. And this one is beta. This is beta. So this will be d by 2. D by 2, this is d by 2, and this is d by 2. So what will be the equation for this chamber? This will be sin alpha by 2 is equal to d by 2 by 2. D by 2 or no. So this will be C alpha will be equal to C inverse alpha by 2 will be sin inverse d by 2. You got 19.1. But what was the value of in question? B is not given. B class we have discussed that V is equal to T sin 180 by 90 minus delta. Only this delta V is given in this. This delta V is 10 mm. So this is the, if you are doing in centimeter, we take this D as, this is 8 centimeter and smaller, this is 60 mm. As this is 60 mm, this is 20 mm or 80%. This side is 8 centimeter, this side is, and delta V is given. So this is 8 centimeter, 51% centimeter, 1 centimeter. Subtract this value, number of feet is given. So from there, d by d you will get alpha. So alpha you can get from there. Similarly, you get beta. Once you get alpha and beta, you will get this area. So this area will be known to you. Area and T is given, number of footed, number of foots is given. Number of feet is given. So area we have calculated, number of foot is there. LF is unknown, where pi G is diameter of footed hill and S is given, stress of activity. So in this side, pi D S is there, LF is unknown. Take LF common and add this A and plus pi D. And volume you have maybe calculated minus. What is the volume coming? Footed. So from there we will get method explaining. Is it clear? Volume for this. So this is clear. We will move to the next sense. So this is fertilizer efficiency. In this we can see that the equipment for granular material include for fertilizer application we have granular application, and then for a sprayer we have non-basic liquid and basic. So granular material we can apply in three ways, that is drop type, rotary type, and kinetic type. Then drop type fertilizer distribution, it may be either broadcast type or banded. Here in this figure you can see banded application. Broadcast means there is no pattern, there is no way to return. Just you type of broadcast. So two ways are there for this drop type fertilizer distribution. And next thing is for rotating type, we have starving mechanism type and auger type. This is auger type. Building orbit, closed fixed orbit, impulse mechanism. This is for rotating type. So for fertilizer application, we have drop type. In rotary, we have this. We have this starving mechanism and this auger mechanism. So this is also interesting. So for in week 8, the first question is a tractor operated 11 into 20 centimeter CG treated product machine is to be calculated for 7 space product. And the speed ratio of treated product to ground release 1:3. Radius of ground release 30, and bulk density is 480 kg per meter. So the volume of seed collected in 10 kilograms we need to find. So first we need to find that in 1 revolution what is the volume of seed. And for 1 revolution of treated product we need to know that what is the revolution that ground release change. Suppose here it is given that treated product to ground release 1:1. Means when 1 revolution treated product is happening, ground release is getting 1.5. So in 1.5 revolution of ground release, what is the seed volume? And this we will get from Great, when you know that in one revolution of ground, one ground will revolution. What is the same? So in one revolution of ground rule, what area it is done. That must be taken. So whether you into 20 supposedly in one revolution it is turning 5 degrees. So this will be A1. Means negative 50 quantities into everything if you do in meters, then it will be 11 into 2.22 into the actual point is this C. Kilograms. This interest by it is covering in one dimension. So in this condition, what is the C part? It is area into 70 days per annum. 70 by 20. We can take it out from the corrector. This will multiply to the get what is the amount of silicon. This is what we are asking volume of seed in volume of seed. So we need to know the density. Our density of seed is 7.4 multiplication. This divided by whole density. Basically, we need to multiply by 6 gas. So this volume of seed is standing in one revolution of ground. We calculate this. You are doing jigyas. $69.08. Okay, wait, so from into 0.2 into 0.4 into 0.6. I'm getting 6.28. Calculate it again, Jigyasa. see 70 into 3 into 11 into 0.2 into 3.16 into 0.6. It is divided by 420 1.3. Okay. 69.08. Just now I got 6.2. Okay. This is in centimeter in one revolution of round wheel. And in 1.5 revolution of ground wheel, what is the seat coming? So that will be for one revolution of rotated wheel. So that should be multiplied with, or 69.08 should be multiplied with 1.5, and that should be multiplied with, that is one revolution of rotated wheel. So that should be multiplied with 10. So this will be in centimeter cube. So 69.08 into 15. 69.08 into 15 centimeter cube will be answer. Okay. 1036.7. So next is, which of the following applicator is used for both broadcasting and banded application of granular chemicals? So we have seen that for broadcasting as well as banded application, which type of spreader is used? It will be drop type spreader. Option B. Okay. So next question is, which of the following is a positive flow metering unit used in granular fertilizer applicator? So what all things we have discussed? Auger type and star wheel was the two mechanism for positive flow metering unit. This was auger one and this was star wheel mechanism. So this two is positive flow metering unit in granular fertilizer application. So both auger and star will be the answer. So next question is, which with any of the auger type metering device, the discharge rate is adjustable by changing. Auger type. So here you can see that with any of that auger type metering device, the discharge rate is adjusted by changing the speed ratio between the auger and the ground. So a speed ratio between the auger and ground wheel is C option. So next is a sprayer. We will move to a sprayer. So here high volume spraying is this application rate is more than 1000 liter per hectare for trees and bushes, and this is for field crop 600 liter per hectare. And for medium low volume it is this one, and for low volume it is this one, and very low and ultra low is less than 5 liter per hectare for field crop. And for non-pressure liquid chemicals applicator, in non-pressure liquid chemical applicator, the gravity drives the liquid flow when it is non-pressure liquid, and it depends on head change. If there is more head change, then more liquid will flow. And there are two types of sprayer for this there is low pressure sprayer and high pressure sprayer, and low pressure sprayer works between the operating range of 150 to 350 kilopascal, and this high pressure works for up to 7000 kilopascal. And here the application rate is 50 to 200 liter per hectare. Here it should be more than that. So for now, this was the just for opening section for a sprayer. In next week we will discuss in deep about spraying. This was just an introduction. So for trees and bushes, the application rate for low volume sprayer in liter per hectare will be. What will be the value for low volume sprayer in trees and bushes? Trees and bushes, low volume spraying. It will be 200 to 500 liter per hectare. So correct option is C. Okay, correct. So next question is, in non-pressure liquid chemical applicator, flow rate is dependent on. So in non-pressure liquid chemical application, we saw that it depends on head change. In non-pressure liquid chemical application, significant variation in flow rate can occur due to a head change, as it flows with gravity. So next is a nozzle. Yes, correct. So a nozzle in a sprayer is specified by. Nozzle also we will discuss in detail in next class. For now, if you have idea of nozzle, you can tell that on a nozzle specification can be specified by. Okay, D is the correct answer. It depends on all, like type of nozzle, operating pressure, volume of liquid sprayed per unit time. Which of the following is not used for applying granular fertilizer on field? So we have seen that. Okay, yes, we have seen that drop type rotary and pneumatic was there for granular application. Drop type rotary and pneumatic was there for granular application. And next question is, high pressure sprayer are similar to low pressure sprayer except they operate under much high pressure, up to 7,000. Just now we have seen. And next question is, we have to match this. So anhydrous ammonium fertilizer, this is for subsurface application. This is, and high pressure sprayer will be used in which type, and the spinning disc will be there for which column? 2B. Okay. No, high pressure is 2A. Yes, high pressure is for orchards, and one will be subsurface application. The spinning disc is there in centrifugal energy. And low pressure sprayer is for low pressure range. We have just seen that 150 to 350 kilopascal. So 1C, 2A, 1C, 2A, 3D, 4B. So D will be the correct answer. So today mic is not working, and we have also we have covered 10 questions. In next class, I will make sure that this mic will work. And till now, if you have doubt for last class also, you can write in chat box. Did you solve week 7 questions? Did you face any problem? Books for what? Like for farm machinery, or for net, or what? For cultivator, one book is there. Uh, I will share you on mail. It is Barnaki. If do you have that book, Barnaki? Do you have Barnaki book? Cultivator is discussed in detail there. And up to week 5, you have one book. Like, do you have Rahman sir? Rahman sir has also written one book on tillage, active and passive tillage, active, passive, and combination tillage implement. Do you have that book? That has comprehensive in that book, like all tillage design and like cultivator will also be okay. I will share you the link of that book. It is there, and like all the tillage implements you can cover from that book. It is written in at one place. Everything is written, so your problem will be solved. I will send you the link. From these assignments, do you have any doubt? Week 7, question 10. This question. This was the last question from week 7. So which of the following statement is not correct for seed tubes? Here correct answer was D. Wait 1 second.
Am I audible?
Ah, yes, now you're audible.
So this time we had the question in week 7 that which of the following statement is not correct for the seed tubes used in seed drill and planter. Like not correct.
Same question, no? Which I am present.
No, options were like all these three were there, and the D we had none of these.
Oh,
So answer what we are getting in the assignment is D.
but the
So
answer
my
will
one
be
marks went like they have marked it incorrect.
okay. Answer should be C. You will get what you will get this marks. I think if some question is gets wrong now, so they consider it. Uh, like I will tell sir, and you will get like sir will tell to NPTEL, and you will get this marks. Means
हाँ
everyone
sir,
will
this
get one.
question only 1 marks I lost. बाकी तो I did like last class whatever we did in the class it was similar a bit, so I did.
Yeah, okay. So this class, do you have any doubt?
Sir, up till now I have no doubts. Like the question also week 8 I have solved, so only one numerical and all the
All are theoretical.
theoretical questions are there.
Yes.
This time also like 18 ko we have our last date. So
Okay, 18th last date for week 8.
week 8, yeah.
Okay, okay. Similar questions must be there, like questions. I think 50% should be repeated. It is like that. The rule is like that. So this time also you will get some same questions. So if you face any doubt in that class, you can tell me. So next class we will discuss about in detail about a
But
sprayer.
all the theory parts are actually it's all distributed like in all the books
Yes,
we
yes.
have. So
Actually,
it's
that book is there. Na, Rahman's book is there. Active and passive tillage implement. So in that book, everything is written in consolidated form at one place. Every design is there. So I will send you that link of that link. From there you can take that book. So if you don't have any doubt from this class, we will end this class, and next class we will discuss the spraying section.
Thank you, sir. And we'll
So we will now solve some numericals related to spraying, uh, as well as we will solve some numericals related to seed drill chapter. So first question here, which is subjective type. Uh, this will help you in solving the, the questions from uh, for the main set that you will get in the NPTEL examination. So first question here is related to seed drill. The question is, a dryland drum seeder of length 60 centimeter and diameter 22 centimeter used for sowing wheat seed in 3 rows with row-to-row spacing of 20 centimeter. The effective diameter of case wheel mounted on drum for its forward movement is 35 centimeter. The maximum weight of seed which can be accommodated in the drum with sufficient free space is 10 kg. Assuming 2 seeds being dropped from each hole, take the test weight as 50 gram for 1000 seeds and seed rate as 1000 kg, 100 kg per hectare. The spacing between the holes in the drum for each row in centimeter we need to find. So a dryland drum seeder of length 60 centimeter. Suppose this is dryland drum seeder and its length is 60 centimeter and its diameter is 22 centimeter. It is used for sowing wheat seed in 3 rows. So one row will be here, one row here, and one row here. 3 rows will be there. And row to row spacing is 20 centimeter. This is 20 centimeter row to row spacing, and it will have some free space on both sides. The effective diameter of the case wheel mounted on the drum for its forward movement. So as we have studied in theory lectures, that there is a case wheel mounted in the drum seeder or seed drill, any seed drill device, which helps to meter the seed, and which helps in forward movement of the drum seeder also. So the effective diameter of the case wheel is given. Suppose there is a case wheel here, which will be attached with this seed drill, and its diameter is 35 centimeter. The maximum weight of the seed which can be accommodated in the drum. So this drum can accommodate weight of 10 kg. Assuming 2 seeds being dropped from each hole, 2 seeds will be dropped from each hole. The spacing between the holes in the drum for each row in centimeter will be. So 2 seeds being dropped from each hole. Means at this row, from each hole, 2 seeds are being dropped. The spacing between the holes in drum. Now the holes which I have made here, we need to find the spacing between those. So how we will approach this problem? So first we will find that what is the distance covered by this drum seeder in one revolution. So it has the case wheel has the effective diameter of 35 centimeters. So in one revolution, it will cover a distance of pi into diameter of this case hole, which is 35 centimeter. We will use everything in meter, every unit in meter, so it will become 3.14 or pi into 0.35 meter. Now, how much area it is covering while it is moving forward? So it is covering 60 centimeter. Here also you can see that 3 rows and row to row spacing 20. So 3 into 20 will be its working width, which it will cover while moving forward. So area covered in one revolution will be this 3 into 0.2 into pi into 0.35 meter square. So it will become pi into 3 into 0.2 into 0.35. 0.659 or 66. It is 0.66 meter square. So in this area, how much seed is being dropped? That we need to next find out. So for that, we need to know that this is the area being covered, and we need to know that what is the seed rate. So here seed rate is 100 kg per hectare. So 100 kg is being dropped in 1 hectare. Means it is 10,000 meter square. So in this much area, how much seed will be there? Means in 10,000 meter square, I have 100 kg. So in 0.66 meter square, it will be 100 into 0.66 by 10,000. So it will become 0.00066. 0.0066 kg or 0.659 it was there. So you can also write 0.0659. So I'm taking 0.66. So this much kg is being dropped in one revolution. Now this amount is being dropped by 3 rows. That is the thing. So in 3 rows, this amount of seed is being dropped. So in one row, the amount of seed dropped will be 0.0 0.0066 by 3. This is equal to 0.0011 kg. It's approximately 0.0022 kg. Now we need to know that what is the number of seed being dropped. So here we can see that in the test it was found that 50 gram of seed 50 gram of seed was containing 1000 seeds. So 50 gram of seeds meant 1000 seeds, and this is in kg. So in gram it will become 2.2 gram. So 2.2 gram of seed will mean 1000 into 2.2 by 50. So this is approximately 44 seeds. So this calculation we are doing for one row. For one row, 44 seeds is being dropped. And we also saw in question that it was written that assuming 2 seeds is being dropped from each row. So 54 seeds will be divided by 2 means 22 seeds will be dropped. So 22 seeds are being dropped per row. That means 22 holes are there in each row. So spacing, what will be the spacing? 22 holes are there, which is dropping 44 seeds. And this 22 holes is there on where on our drum seater, which is having diameter of 22 centimeter. 22 centimeter diameter means what is the circumference of this drum seater? Pi d or 2 pi r. So pi d is the diameter of this drum seater and 22 holes are there. So at what spacing these holes are there, that we can easily find, it will become pi d by 22 or 22 by 7 into 22 by 22. Or you can simply write 3.14 into 22 by 22. So 3.14, this calculation we are doing in centimeter. So 3.14 centimeter will be the spacing between two holes in the drum seater. So I hope this question is clear. A bit lengthy question it was there, but if you know the concept, you can solve it very easily. Now second question is also related to drum seater. This type of question was also there in assignment question, but here we are solving for the final exams. So the question is, a tractor operated 11 into 20 centimeter seed drill with fluted roller meeting unit is to be calibrated for a seed rate of 70 kg per hectare. The speed ratio of fluted roller to ground wheel is 1 is to 1.5 and the radius of ground wheel is 30 centimeter. If the bulk density of seed is 420 kg per meter cube, the volume of seed collected in 10 revolution of fluted roller in centimeter cube should be. So in this question, the seed drill has working width of 11 into 20 centimeter and seed rate is 70 kg per hectare. The speed ratio of fluted roller to ground wheel is 1 is to 1.5. Fluted roller to ground wheel is 1 is to 1.5. If it is 1 is to 1.5, what does it mean? When fluted roller is rotating one revolution, ground wheel is rotating 1.5 revolution. Or in 1.5 revolution of ground wheel, one revolution of fluted roller is happening. So this concept you need to always remember that what is the gear ratio or what is the speed ratio, means in one revolution of ground wheel how much revolution the fluted roller is taking. So that will help you in solving the question from fluted roller side. Now the question is, the radius of ground wheel is 30 centimeter. This is radius, not diameter. That thing is always, people do mistake that radius and diameter you will interchange. So if the bulk density of seed is 420 kg per meter cube, so density is given as 420 kg per meter cube. The volume of seed collected in 10 revolution of fluted roller in centimeter cube should be. So the volume of seed drill collected in 10 revolution of what it is asking, that you need to focus. That it is asking in 10 revolution of fluted roller. So in 10 revolution of fluted roller, what is the volume of seed being collected? So whatever we will do, that calculation will be happening for ground wheel side. So they are asking for 10 revolution of fluted roller, means how much revolution that ground wheel will make for the 10 revolution. So in one revolution of fluted roller, ground wheel is making 1.5 revolution. So 10 revolution of fluted roller will mean 15 revolution of ground wheel. Now we will solve it for one revolution of ground wheel and we will multiply it by 15. So in one revolution of ground wheel, how much area this seed drill is covering? So area covered will be its width of coverage into what is the speed or what is the forward motion or what is the distance it is covering in one revolution. So distance covering by the seed drill in one revolution will be pi into diameter of ground wheel, and for area we will multiply it with what is the width it is covering, which is 11 into 20 centimeter. So if you do everything in one unit, that is meter, so it will become pi into diameter of ground wheel is 30 centimeter, diameter is 30 into 2, that is 60, and in meter it will become 0.6. So 0.6 into 11 into 0.2 meter square. This is the of area that seed drill is covering in one revolution. So what this value will become? Pi into 0.6 into 2.2 is equal to 4.1415. 4.15 meters square. Now this is the area, and after area, if we are to deal with how much is being dropped, we will directly look into what is the seed rate. So here seed rate is given or not. Here seed rate is given 70 kg per hectare. Means for 10,000 meters square, it is we are getting, we need to have 70 kg. So in for 4.15 meter square, how much kg we will get? 70 into 4.15 by 10,000 meters square. This is equal to 70 into 4.15 divided by 10, 0.029 kg. And what we are being asked here is the volume of seed collected. So here it is weight. So there must be some weight and volume relation, and that is density. So density here given was 420 kg per meter cube. 420 kg per meter cube. And we have given that 0.029 kg is being dropped. So 0.029 we will divide by 420 kg per meter cube, and we will get directly volume in meter cube. So 0.029 divided by 420. So it will become this. It will come in meter cube, and what we are being asked in centimeter cube. So in 1 meter cube, how much centimeter cube will be there? 100 into 10 cube, 100 to the power 100 to cube. This will become 0, 0, 0, 0, 0, 0. So it is 0.164. 0.164 centimeter cube, and this is calculation with respect to one revolution of ground wheel. So we will multiply it by 15, as one revolution of ground wheel means 15 revolution of fluted roller. Sorry, one revolution of 10 revolution of fluted roller means 15 revolution of ground wheel. So we will multiply it with 15 to get the value of 10 revolution of fluted roller. So it will become 2.46. Here you do this calculation carefully again, this conversion from meter cube to centimeter cube, and answer is approximately 1036 centimeter cube. So if you're not getting this answer, you can mail, you can write your mail, and we will contact there. And now we will move to next question. So next question is related to a sprayer. Okay, let's solve this again. There was some mistake actually. So if when we will divide this 0.029 by 420, we are getting how much meter cube? We are getting 6.9 into 10 to the power minus 5 meter cube. So this is the volume collected in one revolution of one revolution of ground wheel in meter cube. Multiply it with 10 to the power 6 to get in centimeter cube. So it will become 69.167 centimeter cube, and this much volume is for one revolution, of ground wheel. So 69.167 into 15, you will get 1036 or 1036.7 centimeter cube. So this is the final answer. So next question is, a field spread having 15 nozzles spaced 40 centimeter apart is moving at a forward speed of 3.5 km per hour. The nozzles are said to operate at a pressure of 10.5 kg per centimeter square for an application rate of 1.1 meter cube per hectare. If 15% of the liquid discharged from the pump is to be used for agitation, the required pump capacity in meter cube per hectare is meter cube per hour. So first we need to find what is the capacity, normal capacity of this pump. So field spread having 15 nozzles are spaced 40 centimeter apart. 15 nozzles are spaced 40 centimeter apart and moving at a forward velocity of 3.5 km per hour. The nozzles are said to operate at a pressure of 10.5 kg per centimeter at an application rate of 1.1 meter cube per hectare. So how much area it is covering while moving forward? So what is the field capacity of this sprayer? First we will find out. So it it has a field capacity of 15 nozzles into 0.4 meter into 3500 meter square per hour. So 50 into 0.4 into 3500. So it is 21,000 meter square per hour. And application rate is also given here. The nozzle are set for an application rate of 1.1 meter cube per hectare. So application rate is 1.1 meter cube per hectare. Here also you can find that it is also in terms of area, or it is in terms of meter square. You can see 1.1 meter cube in 10,000 meter square. So we will just multiply it 1.1 meter cube by 10,000 meter square into 21,000 meter square per hour. So what will be, it will become 1.1 into 2.4. It will become 2.31 meter cube per hour. So this is the quantity of liquid discharged per hour. Quantity of liquid discharged by nozzle per hour. And what we are given in question is that if 15% of liquid discharged from the pump is to be used for agitation, of this discharge, 15% is used for pump agitation. So this is 85%. This is 0.85 or 85% is 2.31 meter cube per hour, because 15% was used for agitation. So we will this value is 0.85. So what is 100%? 2.31 by 0.85. So you do this division. This is 2.31 1 divided by 0.85. It is 2.72 or 2.72 meter cube per hour is the answer. So what is the pump capacity in meter cube per hour? It will become 2.72 meter cube per hour. Next question is also related to spraying, related to this week 8 only. So the question given is a manufacturer of pressure nozzle specifies that volume median diameter. Here it is volume median diameter 135 micrometer at a pressure of 145 kilopascal using water having surface tension of 73 dyne per centimeter. The same nozzle is to be used for chemical whose surface tension is 50 dyne per centimeter. The volume median diameter of chemical droplet obtained with same nozzle at 345 kilopascal. So here we have studied one relation between surface tension of surface tension and VMD of both water and chemical. So if you know that relation, you will solve this question in seconds. So what was the relation? VMD of chemical by VMD of water is equal to surface tension of chemical by surface tension of water to the power 1 by 2. So the manufacturer of pressure nozzle specifies that the volume median diameter of 135 micrometer at a pressure of 345 kilopascal using water. So the manufacturer is specifying the nozzle as per water. So water is having surface tension of 73 dynes per centimeter. This is 73 dyne per centimeter, and it is giving the water is giving a VMD of 135 micrometer. The nozzle is to be used for chemical. So the nozzle will be used for chemical whose surface tension is 50 dyne per centimeter. So three known are there and only one unknown you can see. So you can directly solve this question. Here the volume median diameter of chemical droplet obtained is asking if it is same pressure, then only you can apply this formula. If it is operating at same pressure. So we will directly put the values. VMD of chemical by 135 micrometer is equal to 50 by 73 to the power 1 by 2. This implies that VMD of chemical is equal to 135 into root under 50 by 73. One 35 into root under 50 by 73. So the answer is 111.73 micrometer. So this question you will solve if you are knowing that what is known and what is unknown and the relationship you are knowing, then you can solve this question very easily. So next question is again related to a sprayer. The volume mean and surface mean diameter of droplet sprayed with a tractor drawn boom sprayer for a total number of 2401 droplets are 142 micrometer. So if you remember what is the formula for volume mean diameter, we have just studied this formula. Then what is volume mean diameter? VMD is given as sigma NIDI cube by sigma ni to the power 1 by 3. This is the formula for VMD, and for surface mean diameter the formula is sigma ni di square by sigma ni to the power 1 by 2. So this value it is given as VFD is 142 micrometer, and surface mean diameter it is given as 123.8 micrometer. And it is being asked that what is the value of sorted mean diameter. So they are asking that what is the volume of what is the value of sorted mean diameter, and we know that what is sorted mean diameter. It is sigma ni di cube by sigma ni di square. So if we are knowing this value and this value, which is already given in the expression we have just written above, if you should see this carefully, you can see that sigma ni di cube is equal to this to the power cube into sigma ni, or sigma ni we generally write it as capital N. So 142 cube into N, and sigma ni di square is this value to the 2 square into N. So it will become 142 cube by 123.8 square. So when we will solve this, it will become 142 cube divided by 123.8 square. So it is 186.8 micrometer. So the value of this sorted mean diameter is will become 186.8 micrometer. So next question is related to the relationship between the characteristics of the spray droplets. So it is asked that increase in orifice size of nozzle by 20%. If we are increasing the volume mean diameter of droplets obtained from the nozzle operating at a pressure of 2.5 kg per centimeter square will become. So if we are increasing the orifice diameter by 20%, then what will be the effect of on VMD of the droplet? So we need to know that what is the relationship between VMD and orifice diameter, which is denoted as D. So this relation we need to know, and the relation is VMD1 by VMD2 is equal to D1 by D2 to the power 2 by 3. So if you are remembering this formula, then we can easily find what is given in the question. So increasing the orifice size of the nozzle by 20%. So if it is asked that we are increasing D2 by 20%, means D2 is equal to 1.2 D1, it is being said. So the volume in diameter of the droplet, what will happen on VMD2? So VMD1 by VMD2 is equal to D1 by 1.2 D1 to the power 2 by 3, means 1.2 to the power 2 by 3. 1 divided by 1.2 equal to this divided by 2 by 3. So it is 0.88. This is 0.88. So VMD2 you can see is VMD 1 by 0.88. So it is 1.136 VMD1. So VMD2 is 1.13 times VMD1. So what we can conclude from here, that VMD2 has increased by 13.6%. So what will happen? The volume of mean droplet diameter obtained will be what? 13.6% larger than, or this mean this volume mean diameter of droplet will increase by 13.6%. So this will be your answer. So if you have understood these problems, your many concepts will become clear. And if these are clear, then uh, we will solve we will solve some more questions in next week. And if you have any doubts, you can ask the next week. Okay, we will end the class here. Thank you.